Hello, and welcome back to the deep dive. I am so excited for today because, well, I have a very serious, very important question to ask you right at the start.
Oh,
If you could snap your fingers and build a robot best friend right now, what would it be like?
that is a wonderful question to start with.
Huh.
And I feel like everyone has a different answer for this.
Right. Would it be, I don't know, giant and strong like a bulldozer? Or maybe tiny and super fast like a hummingbird?
Mhm.
Or what about a dog that doesn't need to be walked?
I think most people, and probably you listening right now, would say, above all else, they want a robot that is smart.
Oh, yeah.
You want a robot that can tell you stories, answer your questions about, why the sky is blue, and maybe, just maybe, help with your math homework.
Exactly. We want them to be geniuses. We want them to know everything in the world. But here's the problem, and it's a big reason we are diving into these specific science papers today.
Mhm.
Right now, to make a computer brain smarter, scientists have just been making them bigger. And I don't mean just a little bit bigger. I mean absolutely gigantic.
It's becoming a real issue. We're reaching a point where the brains of these artificial intelligences are getting so heavy with information, they're becoming really difficult to run.
Okay, let's paint a picture for you. Imagine you are getting ready for school. You have your backpack.
Right.
Usually you pack your lunchbox, maybe a notebook, a pencil case, and your favorite toy. It's light. You can run to the bus. You can skip.
Sounds like a normal morning.
Now imagine your teacher calls and says, no, today is different. Today, you need to bring every single book in the library on your back.
Oh, wow. That backpack would be bigger than you are.
You wouldn't be able to walk. You'd be stuck on the floor like a turtle on its back, arms and legs just wiggling, trying to stand up.
Right.
That is exactly what is happening to our smartest computers. They're trying to carry everything all the time. And it makes them so slow, and it uses a huge amount of energy.
But, and this is the exciting news, that brings us to the discovery we are looking at today. Some very clever scientists found a way to put down that heavy backpack.
Okay.
They invented something called STEM.
STEM. Now, I know what you're thinking. Usually at school, STEM means science, technology, engineering, and math.
Right.
But in this specific deep dive, it stands for, let me just check my notes here, scaling transformers with embedding modules.
You got it. It is quite a mouthful.
It sounds like a robot sneeze. Scaling transformers. Achoo!
Can we come up with a better name for it for our listeners?
I think for today, we should probably think of it as the super smart shortcut.
The super smart shortcut. Oh, I love that. So the mission for this deep dive is simple. We are going to explain how this shortcut works.
Mm-hmm.
We're going to see how it makes computers lighter, faster, and, this is the crazy part, how it lets us perform actual magic tricks inside the robot's brain.
It really is like magic. It changes the fundamental way the computer thinks. Okay, let's unpack this. To understand the shortcut, we have to understand the slow way first.
Right.
So walk me through this. Let's say I type "hello robot" into my computer. What is happening inside that heavy brain?
Well, in a normal computer brain, what scientists call a dense model, the computer treats every single word like a massive math test.
A math test for every word, even the little ones.
Every single one, even words like the or cat. Imagine you are building a giant Lego castle.
Okay.
In the old way, every time you pick up a brick, you have to solve a giant multiplication puzzle just to figure out where that brick goes.
That sounds exhausting. I just want to build a castle. I don't want to do math for every single brick.
Exactly. It uses a lot of brain power, or what we call FLOPs.
Yeah.
The computer has a specific part of its brain called the feed-forward network.
The feed-forward network.
Think of this as the computer's muscle. Every time it sees a word, it flexes that muscle to calculate what the word means and what should come next.
So it's flexing its muscles for everything. It's doing push-ups just to say hello.
Yes, it's doing heavy lifting constantly, and that is why the backpack feels so heavy. The computer's doing these complex calculations for things that should be simple.
I read in the notes here that scientists tried to fix this before. They tried something called a mixture of experts. That sounds fancy.
It does, and it was a good idea in theory. Imagine that instead of one giant brain doing all the math, you have a room full of specialists.
Okay.
One person knows about space, one knows about dinosaurs, another one knows about math.
Right, so if I ask about a T-Rex, only the dinosaur lady answered.
That's the hope. You don't need the space expert to help with dinosaurs. It saves energy.
Yeah.
But it gets messy.
Messy how? Like a food fight in the cafeteria?
A little bit. Sometimes the computer gets confused about which expert to ask, or the experts start shouting over each other. In science terms, it's called training instability. It's like a classroom where everyone is raising their hand at once, and the computer spends too much time just trying to pick who to listen to.
Okay, I get it. So the heavy backpack is too slow because of all the push-ups and math.
Right.
And the room full of experts is just too noisy and confusing.
Precisely. We needed a better way.
Enter STEM, the super smart shortcut. So how does it fix the math problem without causing a noisy classroom?
This is the brilliant part. STEM realizes that you don't need to do a math problem to understand a word. You can just look it up.
Look it up, like in a dictionary.
Yes. Or think of it like a cheat sheet.
Ooh, I love a good cheat sheet. Okay, let's use an analogy. I'm thinking lockers at school.
Lockers are perfect. So imagine you are at school, it's 8:00 a.m., and you need to find your specific locker to get your gym shoes.
Okay, I'm in the hallway.
The heavy brain way, the old way, would be to take out a map, measure the hallway, calculate the angle of the floor, check the wind speed.
Stop. That's ridiculous. People will be staring at me. I just want my shoes.
Right. Absurdly complicated. But the STEM way is like looking for a sticker.
A stick?
Yes. Imagine you walk down the hall and you see a bright yellow sticker with your name on it.
Yeah.
Boom. You know exactly where your locker is.
Yeah.
You didn't do any math. You didn't measure anything. You just saw the sticker and went, there it is.
That is so much faster. I just walk to the sticker.
That is exactly what STEM does inside the computer. In computer science, we call this a lookup table.
A lookup table. That sounds useful.
It's basically a list for every word the computer knows. Cat, run, happy, space. There is a special sticker, or what we call an embedding, waiting in a list.
Okay.
When the computer sees the word cat, it doesn't do the heavy muscle flexing math. It just points to the cat sticker and says, okay, I have the meaning right here.
It skips the math test.
It skips the hardest part of the math test. The research shows that by using these stickers, we can remove about 1/3 of the heavy parts of the brain.
1/3. Wow. That's like taking 10 heavy encyclopedias out of that backpack we talked about.
Exactly. It makes the model much, much lighter. And unlike the room full of experts, it doesn't get confused. The stickers are always in the same place. The cat sticker is always in the cat slot. It's incredibly organized.
So we have a lighter brain that uses stickers instead of heavy math. That explains the shortcut part of our name. But you promised me magic tricks.
Ah, yes. The magic. This is where it gets really fun.
In the notes, this section is called knowledge editing, which sounds a bit like brain surgery. Can we really edit the brain?
It is a bit like brain surgery, but much, much easier. Because STEM uses these organized stickers, we can do something really fun. We can swap them.
Okay, walk me through the experiment they did. This blew my mind when I read it.
So the scientists took this new STEM computer brain, and they asked it a simple question. What is the capital of Spain?
And the computer said?
It said Madrid, which is the correct answer.
Okay, boring so far. A regular robot can do that. I can do that.
True. But here is the trick. In a normal heavy brain computer, the fact that Madrid is the capital of Spain is hidden. It's mixed into that giant soup of math numbers.
Right.
You can't really touch it. It's like trying to take the egg out of a cake after you baked it.
You can't. It's just cake now. You can't unbake the egg.
Right. But in STEM, the meaning of Spain is attached to the Spain sticker. It's sitting right there in the lookup table.
Ah.
So the scientists reached in, took the Spain sticker, and swapped it with the Germany sticker.
They just switched the stickers. Like switching labels on a jar of jelly and a jar of peanut butter?
Exactly like switching labels. They didn't teach the computer anything new. They didn't rewrite the code. They just swapped the stickers in the list.
So then they asked the question again, what is the capital of Spain?
Yes. The screen still showed the words, what is the capital of Spain? But the computer's brain looked at the word Spain, went to the Spain slot, and found the Germany sticker.
So what did it say? Did it get confused? Did it just say Germany?
It didn't get confused at all. It started giving a history lesson about Berlin.
No way! That is wild! So the computer is reading Spain with its eyes, but thinking Germany with its brain.
And it wasn't just a one-word answer. This is the impressive part. The computer wrote a whole paragraph describing Berlin, its population, the Berlin Wall, the history, everything.
Wow.
It completely adopted the new reality because we swapped the sticker.
Why is this a big deal, though? I mean, aside from being a hilarious prank to play on a geography teacher. Look, teacher, the robot says the capital of Spain is Berlin.
It is funny, but it's also a big deal because of a concept called interpretability.
That's a $5 word. Break it down for our 6-year-old listeners.
It just means being able to understand. For a long time, AI has been a black box. We feed it a question, it spits out an answer, but we don't really know how it got there.
Right.
It's like a secret magic spell.
We want to know how the trick works. We want to see the rabbit inside the hat.
Exactly. With STEM, because the facts are attached to these specific word stickers, we can actually see the computer thinking. We can say, right here in slot number 500 is where the computer keeps its idea of Spain.
That sounds super useful for safety. Like, what if a robot learns something wrong? What if it thinks red light means go? That would be dangerous.
In the old brains, fixing that would be really hard. You'd have to retrain the whole brain.
Yeah.
But with STEM, theoretically, you could just find the red light sticker and swap in the correct definition.
You fix the sticker, you fix the robot.
Ideally, yes. It gives us control. The paper mentioned they did this with other things, too. They swapped United States with California.
Let me guess. It started saying the capital of the U.S. was Sacramento.
It did. It completely understood the swap. It proves that the computer keeps its ideas very separate and organized.
Okay, so we have stickers that make the brain lighter and stickers we can swap to play tricks. But there is one more superpower this STEM invention has, and it has to do with bedtime stories.
The never-ending story problem.
Yes. Listener, imagine this. You know when someone tells you a story that is really, really long, like it just goes on for hours.
Once upon a time, and then 3 hours later, they are still talking.
Exactly. And by the time they get to the end, you've kind of forgotten who the main character was at the very start.
That happens to humans, and it definitely happens to computers. We call this long context. When the story gets too long, normal computers get confused. Their heavy brains get overloaded with all the math.
They lose the plot, literally.
They do. The math starts to get fuzzy. It's like if you mix too many colors of paint together. Imagine you have bright red and blue and yellow and green. If you mix them all in one bucket, what happens?
You just get a gross, muddy brown.
Yuck. Brown paint brain. That is what happens to a normal computer when it reads too much text.
But the STEM computer, it doesn't use mixed paint. It uses those stickers.
Correct. And this leads to one of the most surprising findings in the research. They tested it with a game called Needle in a Haystack.
I know that game. Well, I know the saying. You have to find a tiny needle in a huge pile of hay. It's impossible.
In the computer version, you take a huge amount of text pages and pages of stories, and you hide one tiny little fact, the needle, somewhere in the middle.
Oh, okay.
Maybe it's the secret code, like the magic number is 42. Then you add 10 more pages of story. And then you ask the computer, what is the magic number?
And the heavy brain computers struggle with this.
When the story gets really long, yes, they start to forget. The brown paint takes over.
But the STEM brain.
It was amazing. As the story got longer, the STEM computer actually got smarter relative to the regular computers.
Wait, it got better because the tests got harder? That doesn't make any sense.
It feels like it shouldn't, right? But the statistics show that on really long stories, STEM was about 13% better than the regular dense computer brain.
13% is a lot. That's the difference between a B and an A+ on a test.
Why?
How does it remember the needle when the others forget?
It goes back to the stickers and the organization. Think about a toy box.
Okay, I'm imagining my toy box, and honestly, it's a disaster.
Right. A regular computer's memory is like a messy toy box. You throw the Legos in with the dolls and the puzzle pieces and the cars and the crayons. If I ask you to find one specific tiny red Lego piece.
Good luck. I'll be digging for hours. I might never find it.
But STEM is like a toy box that has a separate tiny cubby hole for every single toy. The red Lego goes here, the blue car goes there, the puzzle piece goes here.
Everything has its own home.
Everything has its own home.
Mm-hmm.
Scientists call this having a large angular spread. But all it really means is that the ideas never touch each other. They never get tangled up. So when the computer looks back through a massive story, it doesn't have to dig through a messy pile. It just looks at the slots.
It sees the magic number sticker sitting in its cubbyhole and just grabs it.
Instantly. It doesn't matter how much other stuff is in the room because the sticker is in its spot.
That is so cool. It's not just lighter, it's just tidier. It's like the Marie Kondo of robots.
That is a wonderful way to put it.
Mm-hmm.
It sparks joy by being organized.
So we have a lighter brain, a magic swappable brain, and a super organized brain. I have to ask, does this save energy? Because if I tried to organize my room perfectly, I would be exhausted.
For a human, yes. Organizing is hard work. But for a computer, being organized saves a massive amount of energy.
How much are we talking?
A lot. Remember we talked about FLOP?
FLOPs.
The funny word for math calculations?
Right. Because STEM uses the cheat sheet or lookup table, it skips the hardest calculations. Less math means less energy. But there is another benefit, too, for the computer's memory.
Is this where we talk about VRAM?
Yes, VRAM.
VRAM sounds like a robot villain.
Oh, yeah.
I am VRAM the Destroyer.
It really does. But it's actually more like the robot's backpack space. It's the video random access memory. Usually that gets full very fast. But STEM allows us to do something called CPU offloading.
Offloading, that sounds like giving your chores to your little brother.
It is exactly like giving your chores to your little brother.
I knew. See, the computer have a main brain, the GPU, that is super fast and expensive. It's like the race car driver. Then it has a helper brain, the CPU, which is a bit slower, but reliable, like a pit crew.
Okay, so the race car driver wants to go fast.
Right. Because the STEM stickers are just a static list.
Yeah.
They don't change. We don't need the race car driver to hold them. We can give that list to the pit crew.
So the helper brain holds the cheat sheet.
Correct. This frees up the main brain to focus on the really important thinking. It makes the whole system run smoother and cooler.
So it's efficient, it's fast, but I have a worry usually when I take shortcuts, my work gets sloppy. You know, if I do my homework really fast so I can go play, I might get some answers wrong. Does the STEM computer get worse grades because it's using a cheat sheet?
You would think so. That was the big worry the scientists had. Is it cheating to use a lookup table? Will it make the robot dumber?
Yeah.
But the results were shocking. It actually gets better grades.
Better grades. For doing less work. That's not fair.
I know. They tested this STEM brain against the heavy, dense brains on some really hard tests. One was a math test called GSM-8K, which is full of tricky word problems.
Okay.
And another was a science test called ARC Challenge.
And it beat the heavy brains.
It beat them. It scored around 3 to 4% higher than the computer that was doing all the heavy lifting.
That is incredible. So let me just recap this because we've covered a lot.
I fart.
We have a new way to build brains called STEM. It works by using stickers or a lookup table instead of doing hard math for every word.
Correct.
This makes the brain lighter, so it's like taking books out of the backpack. It makes it easier to play magic tricks by swapping facts. It helps it remember super long stories because the toys are organized in cubbies. And it saves energy while getting better grades.
That is the perfect summary. It really challenges this idea that bigger is always better. In AI, it turns out that smarter and more organized is the real winner.
It's like realizing you don't need to memorize the whole encyclopedia. You just need to know how to use the index to find what you need.
Precisely.
So let's bring this back to our listener who is sitting there, maybe playing with Legos right now. Why should they care about STEM and these sticker brains? Why does this matter to a kid?
Well, think about the devices you use. Maybe you have a tablet that reads to you or a smart toy robot that talks and walks.
Yeah.
Right now, those toys usually have to connect to the internet to be really smart.
Because their brains are too big to fit inside the toy.
Exactly. The brain is actually in a giant computer far away. If the Wi-Fi goes out, the toy gets dumb. It can't answer your questions anymore.
A sad, dumb robot. That's no fun.
But with STEM, because it's so much lighter and efficient, and because of that offloading trick we talked about, we might be able to put these super smart brains directly inside the toys.
So my robot dog could be a genius even in the car, even if I'm camping in the woods.
Yes. It means our electronics can be smarter, faster, and the batteries will last longer because they aren't doing as much heavy math.
That is a future I am excited for. A robot that helps with homework, tells perfect bedtime stories, and never needs to be plugged in. Sign me up.
We aren't quite there yet, but STEM is a huge step in that direction.
We have covered so much today, from heavy backpacks to magic stickers. It's amazing to think that scientists are still figuring out new ways to build brains. You'd think they knew everything by now.
That's the beauty of science. There's always a new way to look at a problem.
Yeah.
We used to think we had to calculate everything. Now we know we could just look it up.
Before we go, I have a final thought for you, the listener, to chew on. We talked about how we can swap stickers in the computer's brain. We swapped Spain for Germany. But imagine if you had the control panel for a robot brain.
Oh, this is a dangerous question. Let's see where this is going.
If you could swap one sticker to change a fact in the computer's world, what would you change?
That is interesting.
Would you make it so that the word vegetables actually means candy? So the robot tells your mom, he needs to eat more candy for dinner, it's healthy.
Or maybe swap walking with flying.
I'm gonna fly to school. I like that. Or maybe swap bedtime with party time.
I think if I swapped homework with video games, a lot of kids would be very happy, but a lot of teachers would be very confused.
The robot would look at your math sheet and say, "Ah, yes, your assignment is to play 3 hours of Minecraft." That sounds pretty good to me.
Just remember, if you do that, you might get a very strange report card.
True. But that's the magic of STEM. We can see where those facts are, so keep asking questions about how things work. Because even the smartest computers are just big puzzles waiting to be solved.
Absolutely. Keep wondering why.
Thank you for diving deep with us today into the world of STEM and robot stickers. Keep learning, keep curious, and we will see you on the next deep dive.